Hello and welcome back to another one of these preparing for A-level maths videos. So once again, if you look in the link in the description, there is going to be this worksheet that you can access and you can download. Again, I'd recommend going through this video now and then doing the worksheet a day or two afterwards just to see how much you've retained. But we're going over something that again we've covered before in GCSE called completing the square. However, there are a few kind of new pieces as per usual. As always, that will come up in AS. Now, I want to preface this. Technically, this isn't everything that's in completing the square. And the reason why I left this out, I did debate it. I had it in originally and then I deleted it. Because you also use this with equations of circles. So what they'll do is they'll give you some long expression and they'll ask you to work out the equation of the circle. And you have to use completing the square for that. Now, the reason why I left it out is because there's going to be a video on equations of circles, so I'll just do it then, as opposed to going over this now. But this, again, illustrates my point that it's very hard to look at subjects or topics individually because they all link together and come back again and again and again. You will be expected to recognize when you can use completing the square and when you should. Now, completing the square is basically another form of factorizing, okay? So you can use it to plot graphs, you can use it to find the minimum or maximum points, and you can use it in order to solve them if you'd like as well. So if you want to give an answer in third form. Less common now because, of course, you don't have a non-calculator paper, so realistically you wouldn't ever really need to use completing the square to do it, but if they ask you to, you're expected to know it, okay? But just to keep that in mind, that if you're wondering about the equations of circles and things like that, that's in the equations of circles video that hasn't come out yet, but in the future it will be, of course. So, completing the square, let's go with what that means. Completing the square is quite simple. All you have to do is look at an algebraic expression like so. So x squared plus bx plus c, and you can write that as x plus b over 2 squared minus b over 2 squared plus c. Now if you notice, and this is something that I really want to hammer home because a lot of students in their year 12 mocks get this wrong, there is nothing in front of this x squared, which means it's a 1, okay? It's not minus x squared, it's not 2x squared, it's not half x squared, it is nothing, it's just the number 1, okay? If you have something in front of x squared, you factorize it out. That's the key point that I really, really, really want to hammer home, okay? Because a lot of students get that wrong. So, if we have a look at this, it says show that this expression is greater than 0 for all real values of x. Now, I can already hear some of you typing. You cannot use the discriminant for this. The discriminant will just show you, so if you, those of you that haven't done the discriminant, that's coming up in a later video as well. But you can't just solve this equation, right? So if I solve this equation, I'm going to get no solutions, right? Because it's greater than 0. That doesn't show that it's greater than 0 for all real values. It just shows that it doesn't equal 0, which is not the same thing, okay? Because again, we have graphs like so. This is the 1 over x graph, where it goes from positive to negative without going through the origin, which means it never equals 0, but it can be positive, can be negative. Now, of course, you might say, but it's a quadratic. You're right, but we're trying to teach you how that if you're trying to show that a function is always greater than 0, you have to be very rigorous. You can't just say it doesn't equal 0, therefore it's not 0. You have to actually show that it never, ever goes down to 0, okay, or goes below 0. So, we're going to be using completing the square, and if we use this, b is just negative 6, and c is 11. So just subbing this straight in, we have x, and of course it's a minus instead of a plus because we have minus 6. b over 2, what's 6 divided by 2? That is 3. Squared minus, again, 3 squared plus 11. So we get x minus 3. Now all we're going to do is expand this part over here. One thing you can do, and I would encourage you to do this, is to just enter this bit into a calculator. So you have minus 3 squared plus 11, right? It gives you 2. Minus 3, or minus of 3 squared is minus 9, plus 11 is plus 2. Plus 2. Now this is always greater than 0. Why? Because the smallest this can be, so smallest is equal to 0. Now why is that the case? Well, let's have a look. If I make x positive, then it gets bigger and bigger and bigger and bigger, right? So it's positive. A positive number squared is always positive. If it's 0, I get 0 squared, which is 0. So it equals 0. Now what happens if I make this negative? Well, a negative number squared is also positive. So we have, when x is less than 0, it's positive. When x is greater than 0, it's positive. Or when the whole thing is kind of negative, the whole thing's positive, it's 0. Above 0. And when it's equal to 0, it just equals 0. So the smallest this can be is 0, and then we're adding 2 to it. So 0 plus 2 is always greater than 0. Of course, right? So if that makes sense. When you do things in completing the square, you get the minimum point. So the smallest this bracket can ever be is 0. Right? Because if it turns out to be, if x minus 3 is negative, we square it and make it positive. If x minus 3 is positive, we square it and keep it positive. But if x minus 3 is 0, then we square it and it stays 0. Which means that is the smallest number it can be. Quite an easy one to start with. Then it says, prove that for all values of x, this is greater than x plus 3. And I've seen students try and use completing the square on this side and then try and do some mental gymnastics. It's not that bad. If you ever have an inequality with letters and numbers on both sides, move them all to the same side. So I'm going to take all of this and I'm going to move it to the left-hand side. So I'm going to minus x and I'm going to minus 3 from both sides. So x squared stays the same. 4x minus x is 3x. And 12 minus 3 is 9. So you always want it equaling 0 on the right-hand side. And this is the same when you solve equations, right? You always want them equaling 0 because that gives you the most flexibility. Just keep that in mind. So again, we're going to use this formula here. So b over 2. B in this case is 3 and c is 9. So we have x plus b over 2. So that's 3 over 2 squared minus, and then that's going to be 3 over 2 squared again, plus 9. And then it says greater than 0, but we'll leave it as that for now. So the next thing I want to do is I want to write this into my calculator. So we have minus, open bracket, 3 over 2 squared plus 9 gives me 27 over 4 or 6.75, whichever you prefer. So we have x plus 3 over 2 squared plus 27 over 4, and that is always going to be greater than 0 because again the smallest this can be is 0, which means again it's always going to be greater than 0, right? 0 plus a number is always going to be bigger than 0 all the time. Nice and easy, I hope. Now here's where things get a bit interesting. So I could tell, like, I have precognition. A few of you probably found that boring, but this is where we get to some meat and veg. So by completing the square, find in terms of the constant p the roots of the equation. Ooh, that's a bit interesting. But it's actually the same thing. Okay. So this is where solving equations can be useful with completing the square. Again, I said it's very unlikely they'll give you this because we have calculators. However, if they give you an unknown, that's when things get interesting, because how do you plug in an unknown into that equation, the quadratic formula? You can't. So in this case, we have b is equal to p, which might be a bit odd, and c is equal to 4. So once again, we're just going to write down x plus p over 2 squared minus p over 2 squared plus 4 equals 0. And again, it does say find in terms of the constant p the roots of the equation. So remember, roots just mean solutions. So what I want now I've got this is I want to rearrange for x. That's the key thing that I'm thinking of. So if I want to rearrange for x, what I might want to do is instead of doing this square, like squaring this, I might just want to move this whole thing to the right hand side. But again, in case you didn't kind of think of that, let's expand the brackets first. So we have x plus p over 2 squared minus p squared over 4 So again, when you square a bracket, you square the numerator and the denominator. So p squared is p squared, 2 squared is 4, plus 4 equals 0. Now, when we solve, we want to move everything over to the right-hand side. So let's do that. We have x plus p over 2 squared equals p squared over 4 minus 4. Now we're going to square root both sides, but remember what you can't do is treat this individually. So if I square root both sides right now, which is what I'm going to do, I can't write this. Wrong. Completely and utterly wrong. Okay? Instead, you simply write a big square root, and it looks a bit ugly, I completely get that. In A-level maths, we do get very ugly looking formulas and equations and answers, but that's fine. Okay? That's what you have to do. Then the lastly, but certainly not least, technically this would be plus minus, by the way. Keep that in mind. When we square root now, we need to put plus minus. We have x is equal to, we're minusing p over 2 from both sides, plus minus the square root of p squared over 4 minus 4 minus p over 2. And that's our 3-mark answer. There's no real way we can make that look better. Maybe we could put the minus p over 2 at the front. So you might see answers where they instead do this. And some people say, well, is it still right if we have the first answer? Absolutely. This is just purely a semantic change. What I mean by that is I've written the same thing in a different way, right? It would be like me writing, 2 times 2 versus 2 squared. It's the same thing. No one's going to grade you down for writing it in a different way, okay? Unless they specifically say, give it in terms of this. Cool. Now for part B, it says, hence find the set of values of p for which the equation has no real roots. Now, this is where it gets a bit more interesting again. So, hence means we need to use part A. So I'm immediately thinking we're going to use this. Immediately. Where it has no real roots. So we don't deal with non-real roots. So just so you're aware, there are always extra solutions to equations. There is a solution to every problem, essentially, with quadratics. However, some of them are real, some of them are imaginary. Now, unless you're doing further maths, you will not deal with imaginary numbers, okay? So don't worry about it. But just for context, so you understand where this kind of fits in, imaginary numbers happen when you square root negative answers, okay? So if I square root negative 1, that is an imaginary number, okay? So when it says no real roots, effectively, it's whenever you're square rooting something, it can't be less than 0. For us regular maths people, if you're further maths, you live in a different dimension, okay? So you have access to imaginary numbers and all that stuff. But again, for this context, and by the way, it's also an important thing, further maths and pure maths. If you're doing further maths, I'm fairly certain you have to do regular maths as well. At least that's the way I've always experienced it. You can't use further maths in regular maths, right? So you can't talk about imaginary numbers in regular maths. So please avoid that. So, are there any limits for our solutions? Absolutely, there are. Whenever you have a square root, there is a limit to your answers. That limit is when this thing here, inside here, is less than 0. So, what I'm going to do is find the set of values for which the equation has no real roots. That happens when p squared over 4 minus 4 is less than 0. So if we want to find the set of values, and this is another key thing, when it says set, it means you're going to be using an inequality because it implies there's more than one value. So if you get p equals 2, it's probably not the right answer. You probably need some kind of inequality. Now if I solve for p, all I need to do is add 4 to both sides, so I get p squared over 4 is less than 4, times both sides by 4, p squared is less than 16. Square root both sides, I have p is less than plus minus 4. So essentially we can't have p squared being 4, right? So p cannot equal plus or minus 4. Hopefully that makes some amount of sense in that regard. But effectively we can't have p squared over 4 being less than 4. Here's another very typical year 12 mock exam question where you have completing the square, and then immediately you need to apply your knowledge of completing the square. So again, if you'd like, take a second to attempt this question for yourself. Again, use this as active learning. So treat it like a lesson. I go through a question, you attempt the next question, check your answer, and then attempt the next question, check your answer, attempt the next question, check your answer, okay? Unless it's something brand new. It is what I thoroughly recommend if you actually want to learn this stuff. So attempt it before I go through it. So express x squared plus 9x plus 3 in the form this. Nice and easy. All we need to do is b's number is 9 and c is 3. So we have x plus 9 over 2 squared minus 9 over 2 squared plus 3. Now what I want to do is just enter into my calculator this kind of numerical expression at the end. So again, we got minus 9 over 2. And again, be careful with the kind of, first of all, if you ever want to square fractions, they have to be in brackets. Please, for the love of God, don't put the minus inside the brackets. You get a completely different answer. This thing here is always negative, because when you square something, it's always positive. When you put a minus sign in front of it, it's always negative. So be very astutely aware of that. Minus 69 over 4, perfect. And now it says for part B, so that's 2 marks, 2 steps. Part B is so generous. It is so generous. State the turning point, right? Or state the minimum point or the maximum point. The reason why this is generous is because it's literally 1 step. You should remember this from GCSE. Basically, when you put something in completing the square, you get the turning point. You get the maximum or minimum point straight away. All you need to do, and I'm going to show you the answer, then I'm going to show you the reason why, just like I did with GCSE. The answer is this. You flip the sign of whatever's inside the bracket. So I flip the sign. Instead of plus, it's going to be minus. If it's minus, it'll be plus. And that's my x coordinate. And then I write the exact same thing here, whatever that is, minus 69 over 4. That's 2 marks. So generous. So generous. So, why is this? Well, if you think back to the previous questions we did, I mentioned about the minimum value of our, like the smallest we can make our equation. And what I did is I made this equal to 0. Okay? So if I'm trying to make this bracket equal to 0, I can write that as an equation. I can say x, I don't really need a bracket there, let me get rid of that. I can say x plus 9 over 2 equals 0. So then all I need to do is minus 9 over 2 from both sides, and I get x equal to minus 9 over 2. And that makes that bracket as small as humanly possible, which is why it's the x coordinate. Now, if I have that x coordinate, then this bracket is equal to 0. What am I left with? I'm left with whatever's on the end. So that's why it works. It's a really elegant, simple way of finding minimum and maximum points. Again, if you've done further maths, you've probably done differentiation. If they tell you in part A to use completing the square, which is what they're doing here, if you ever see this form, it means completing the square. 100% guaranteed completing the square. So using that, you should work through it. You shouldn't differentiate really, although technically you'd be in the right. Once again, we have these kind of weird algebra style questions. So by completing the square, find in terms of the constant k the roots of the equation. Again, that just means solutions. Have a go, please, at doing A and B. So I'll give you a few seconds. Let's go through it. I'm assuming you've at least had an attempt. Let's go. So first of all, again, by completing the square, they're literally telling you what to do. So just do completing the square. B in this case is k. C is minus 6. So we have x plus k over 2 squared minus k over 2 squared minus 6. Okay? Easy peasy lemon squeezy. And we should make this equal to 0 technically as well. Then we're going to, again, what we did last time, it says find in terms of the constant k. Well, that's what we did back up here. And this, again, is why I love A-level maths. And I know that there are people that are going to disagree with me. A lot of questions are the same thing, they just change the numbers. So if you practice this huge range of questions that I'm trying to give you, and then just try and do every question you can, you're going to be prepared for like 80% of your exam. And think about that. 80% is A star A territory. Okay, so you can always guarantee yourself an A if you do this. So, again, what I did is I moved everything over to the right-hand side. So let's do that. X plus k over 2 squared. and then I'd have k over 2 squared, oops, equals. Cool. I'll expand that bracket now. You could have expanded it first, completely up to you. Really doesn't make a difference. So we have k squared over 4 plus 6. Square root both sides. Again, we can't actually do the square root, so we're going to just leave it in terms of a surd. And then again, that would be plus minus k squared over 4 plus 6, and then minus k over 2. I went one step too far. That's actually the answer. Whoopsies. Then minus k over 2 from both sides. We get x is equal to... And again, I'm going to show you the other way to write this. So you can also have minus k over 2 first, plus minus the square root of k squared over 4. Again, not the prettiest solution, but it is the solution. And that's 4 marks. Not bad, right? You get 2 marks just for doing completing the square. Then 4 marks. Like 2 more marks for rearranging. Not bad, I'm hoping you're seeing, right? In A-level maths, I'm hoping this is making you not as scared. Because the biggest jump is from GCSE to, from year 11 to year 12 is quite a decent sized jump. That's not too bad, hopefully. And again, if you put this minus k over 2 afterwards, also valid. Don't let anyone tell you otherwise. Now for part B, I'm actually going to do this next to this equation, this question, just so we can kind of see it much more clearly. It says hence. So again, immediately, I'm just going to write out this exact same formula again, because it says hence. Hence just means using the previous part in terms of maths anyway. For those of you doing English, you can probably tell me the actual definition of hence. But for maths, this is completely doable. Find the roots of the equation here. Now, this is what I do. The first thing I notice is that it's a different equation. Okay? It's not k, it's 4. And then I think, okay, it's different, but how's it different? Well, the x squared's the same, the minus 6 is the same. The only difference is that k equals 4. So what do you think I'm going to do? I'm going to sub in k equals 4. That's it. That's the intended solution. And it says find the exact roots. So essentially all you need to do is do minus 4 over 2 plus minus square root of 4 squared over 4 plus 6. So now what I would do is I'll just simplify this. So we have minus 4 over 2 is just going to be minus 2 plus minus. Ever unsure? Use your best friend, the calculator. In fact, we can actually even... let's actually see what it equals normally. So 4 squared, I'm just going to put what's inside the bracket for now. It should just give me 10. So yeah, it's going to be square root 10. So plus minus square root 10. Done. Right? Not too bad, hopefully. And now we're on the very last question of this one. And this is, again, a harder style for 2 reasons. The reason I love this question because A, notice it's not 1 in front of x squared. Okay? Which means we have to use our formula. Should I have said that a bit later on when you've had a chance to pause the video and try yourself? Absolutely, I should have said it later on. But, again, hopefully you just paused it beforehand. Anyways, so we're going to have to do a little bit of a trick there. Give it in this form. Cool. If there is a letter in front of the bracket, it means that there is a number in front of x squared. Just as a little bit of a hint, okay? And then we have some other business to do. So, let me show you how to properly deal with this. So we have, bear with me one second. There's actually a few different ways to do it. Now, I can leave this plus 8. I'm going to move it slightly further away. And what I'm going to do is I'm going to factorize this first bit. Okay? So, I want there to just be x squared. So I'm going to factorize anything that's not x squared. So I'm going to make it minus 3, open bracket. That will make it x squared. And what is 12 divided by minus 3? It is minus 4. Okay? And then we have plus 8 on the end. Now we're going to do completing the square using this. Now, here's something I want to preface. Some people like to also factorize out the 8. So they like to factorize 3 from the 8 to make it minus 8 over 3. Completely fine. So what I mean by that is you could also have something like this. And you'll get the same answer. Do completing the square with this, you'll get the same answer. It's personal preference. Now, If 8 was divisible by 3, so let's say it was plus 9 instead, I would do this. I prefer it. If it's not a fraction. Again, completely up to you. Your choice. Don't worry too much about it. And then we're going to do completing the square with this bit. So we're going to have minus 3. I'm going to use staple brackets. You're going to see me use staple brackets a hell of a lot during this A-level maths course. Because when you have 2 layers of brackets, it's very awkward to just put like another layer of bracket. Because you can't always see where one bracket starts and one ends. And keep in mind, we might have 3 layers of brackets in our answers, especially when we come on to integration. So I'm just going to put it out there. The inner layer is going to be normal brackets. Then it's going to be staple brackets. Okay. The third layer, I use curly brackets, but we don't really need that just now. Then we have another bracket. We have x squared minus 4. So b is minus 4. We don't have a c. That's completely fine. So we have x minus 2 squared minus 2 squared. And then the plus 8's on the end. Let's expand the bracket on the right hand side. So minus 2 squared is 4. That makes it minus again. So minus 4 plus 8. Now we're going to expand the staple bracket. So we're left with minus 3 x minus 2 squared minus plus even. So minus 3 times minus 4 gives me plus 12 plus 8. So our final answer is minus 3 x minus 2 squared plus 20. Again, I write out every single step because it's very easy to make a mistake. You guys have seen me make mistakes before. I'm a human being, believe it or not. So it does happen on occasion. But writing out every step individually helps your brain actually work through things properly. Lastly, it has a turning point at M. Find the coordinates of M. I want you to, everyone, I don't care who you are, stop the video. I'm going to give you, just take 10 seconds, think about what you would think the turning point is. And what I'm going to do is I'm going to move this over in case you haven't paused it. And that forces you to actually think about what you're talking about. Okay, now, let's go through it. Here's the answer, just in case you guys want to check. That's the answer. This number at the front has no effect on the minimum or maximum point. Because remember, we make the bracket equal to 0. What is any number times 0? 0. So it does nothing. It does absolutely bugger all. Okay? Likewise, does this minus 3 affect the 20? No. So it's the same method. You flip the sign inside the brackets, and that's your x. And you keep this the same, that's your y. Done. And again, if you wanted to practice, again, one key thing with A-level maths is since there's a lot to remember, working it out can be a preferable alternative. What is the smallest this can be? The smallest it can be is equal to 0. Well, minus 3 times 0 would be 0 plus 20. That's my y coordinate. And how would I make this equal to 0? Well, x would have to be 2. That must be my x coordinate. Done deasy. So again, link in the description for this worksheet. I would recommend attempting it again in a day or two, just to see how much you know. Keep in mind, it's only like 5 questions, right? I don't want to overload you with questions. If you want to find more questions, you can do all sorts. These are from the past papers, though. The year 12 papers, not the year 13 ones, not the A2s. Although I can use this as well. The reason why I didn't take the year 13 ones is simple, because there's a lot of extra stuff in there. Even in terms of, like, you do completing the square and then there's like 5 parts after it. So I didn't think it was worth it. But I hope you enjoyed. If you have any questions, again, leave them in the comments. And I hope you have a wonderful day.